of gases. Our third conclusion is, at constant temperature, where kH being constant, as the pressure is increased, mole fraction X will also increase, and solubility of a gas increases on increasing pressure. Here I would like to give you some practical illustrations of this conclusion. Everybody is familiar with the soft drinks. Carbonated soft drinks are good examples of Henry's law. They are packed at high pressure in a vessel filled with carbon dioxide gas, some of which dissolves in the drink. When you open the can or bottle, the partial pressure of carbon dioxide gas above the solution drops. So the concentration of carbon dioxide gas in solution also drops. That's why we see gas bubbles coming out of the solution. The same can happen with gases dissolved in your blood if you are an underwater diver. Here, it is worthy to note that deep sea divers do not use a mixture of oxygen and nitrogen for breathing. Rather, they use helium-oxygen mixture. Why this is so? It's because nitrogen is soluble in blood. So if one breathes at high pressure mixture of oxygen and nitrogen in deep underwater, there can be appreciable concentration of nitrogen in the blood of the diver. Now, when the diver ascends too rapidly, the nitrogen is released as the pressure decreases and forms bubbles in the blood. This affliction, sometimes called bands, is painful and can be fatal if blood is forced out of capillaries and the brain, for example, is deprived of oxygen. Since helium is not nearly as soluble in blood as nitrogen, hence divers use helium-oxygen mixture instead of nitrogen-oxygen mixture. Similarly, at high altitudes, partial pressure of oxygen gas becomes less in the air. Hence, concentration of oxygen in the blood also decreases. Due to that, climbers feel weak. This symptom is known as anoxia. Now, I would like to give you some important exceptions. Most gases obey Henry's law. But still, there are some exceptions, mainly due to chemical reaction between the dissolved gas and the solvent. For example, number one, solubility of ammonia in water. According to the equation, NH3 plus H2O equal to NH4 plus OH minus. The second exception is solubility of carbon dioxide in water. Carbon dioxide reacts with water, forming carbonic acid. The chemical equation is CO2 plus H2O equal to H2CO3. The third exception is about the solubility of oxygen in blood. Normally, oxygen gas is only sparingly soluble in water. However, its solubility in blood is dramatically greater because of the high content of hemoglobin Hb molecules. Each Hb molecule can bind up to 4 oxygen molecules, which are eventually delivered to the tissues for the use in metabolism. According to the equation, Hb plus 4O2 equal to HbO2 whole 4.